So let's write out a few terms of this series. I'll have this. The sum as n goes from 1 to infinity of 1 over 2 to the n. Well, when n is 1, what is the term? What's the first term? 1/2. When n is 2, it is 1/4. When n is 3, it's 1/8. When n is 4, 1/16. So there's my series. And to determine whether or not it converges, one thing I can do is look at partial sums. So let's look at some partial sums. S sub 1, that's the sum as n goes from 1 to 1 of 1 over 2 to the n, and that's 1/2. S sub 2 is the sum as n goes from 1 to 2 of 1 over 2 to the n, so that's 1/2 plus 1/4. Looks like I need a common denominator. It's going to be 4. So that would be 2/4 plus 1/4, and I get 3/4. S sub 3 is the sum as n goes from 1 to 3 of 1 over 2 to the n. That's 1/2 plus 1/4 plus 1/8. Oh, that should be an equal sign right there. Equals. Well, these two, when I added them, I got 3/4. So this is 3/4 plus 1/8. 3/4 plus 1/8. Common denominator will be 8. So 3/4 is 6 over 8. That's plus 1/8. S sub 3 is 7 over 8. S sub 4 will be the sum as n goes from 1 to 4 of 1 over 2 to the n. And from that previous comment on S sub 3, S sub 4 should be S sub 3 plus one more term. And what's that one more term? 1/16. S sub 3 was 7/8. 7/8 plus 1/16. Common denominator 16. So 14 over 16 plus 1/16. I get 15 over 16. Zoom out a little bit. Okay. There we go. So as I'm looking at the partial sums, you could probably make a guess on what this series converges to. Here is a sequence of partial sums. S sub 1 was 1/2. S sub 2 is 3/4. S sub 3 was 7/8. S sub 4 is 15 over 16. What does it look like S sub 5 would be? 31 over 32. So it looks like S sub 5 is 31 over 32. How'd you get that? What's happening in the denominator? This is kind of back to your question earlier. Like, how do you see the pattern? What's happening in the denominator? It's doubling. So it's being multiplied by 2. And the numerator is 1 less than the denominator. So S sub n, the denominator is 2 to the n, and the numerator is 2 to the n minus 1. That I can reduce, or I could write it like this. I can split this into 2 fractions, 2 to the n over 2 to the n minus 1 over 2 to the n. And the 2 to the n over 2 to the n reduces to 1. That's 1 minus 1 over 2 to the n. So there's an expression for S sub n. Remember our series? What about the series as n goes from 1 to infinity of 1 over 2 to the n? Well, that's going to be, I'll write this again. The series as n goes from 1 to infinity of 1 over 2 to the n is going to be the limit as n approaches infinity of S sub n. And that's the limit as n approaches infinity of 1 minus 1 over 2 to the n. Now, as n gets bigger and bigger and bigger, this 1 over 2 to the n is going to go to what? 0. Here, I'll put a little line through it and do 0. So this limit is 1. This series converges, and it converges to the number 1.